Welcome to our lesson on geometric sequences. So today we're going to identify the properties of a geometric sequence and determine its explicit rule. So let's start off by defining what a geometric sequence is. So geometric sequences are formed by repeatedly multiplying by the same number. Mathematically, a sequence is geometric if the ratios of consecutive terms are equal. So a term, an divided by the previous term, an minus 1, is equal to r. R is called the common ratio. You might be wondering, why are we calling this geometric? So if you think about multiplying is how we calculate something like area, and area is a geometric property. Yes, so multiplying, area, geometric. So let's look at a couple examples. We want to determine if the following sequences are geometric. If yes, identify the common ratio. So we can check by dividing each of them by the previous term. So 64 divided by 32 is 2. 32 divided by 16 is 2. 16 divided by 8 is 2. 8 divided by 4 is also 2. So the common ratio, first, we know this is geometric, and the common ratio is equal to 2. We can also show this as you go from 4 to 8, it's times 2. As you go from 8 to 16, it's times 2 again, then times 2 to get to 32, times 2 to get to 64. So let's look at the second one. Suppose I can have all three of these on the screen at the same time. So to go from 2 to 4, we multiply by 2. But then when you go from 4 to 12, notice that we multiply by 3. So this one is not geometric. It has no common ratio, and we're able to conclude that immediately after this multiplication factor differs from one to the other. So for number 3, we are starting with a sequence of fractions. So if I rewrite this just slightly, it's 1, negative 2 over 3, 4 over 9, negative 8 over 27, and then lastly 16 over 81. Now we can look at this, instead of saying we're starting at 1, let's say we're starting at 1 over 1. And so we go 1 to negative 2, negative 2 to positive 4, 4 to negative 8, and 8 to 16. So that sounds like we're multiplying the numerator by negative 2. And then on the bottom, you go times 3, times 3, times 3. So we go from 1 to 3 to 9 to 27 to 81. And each of these we're multiplying by 3. So our common ratio is actually a fraction, negative 2/3. And so this is what makes this sequence geometric. So in the next video, we'll look at how to write a formula for geometric sequences. And so we'll pick it up there.